Hello, my name is Norman Packard, and I'm a founder of Protolife, and I'm here to give you a tour of PDT, which stands for Predictive Design Technology, a tool for optimizing complex experiments.
We assume that you have already signed up, which you can do with this button, and that you can log in, which I will now do. Logging in takes you to the dashboard, the PDT dashboard, and that's basically Command Central for controlling PDT sessions. There's various information on this page, like documentation of PDT, different types of documentation at various levels of detail. But over on the right here, we have an image that captures the essence of PDT. And really what PDT is trying to do is help you improve your experiments. We presume that you're doing some sort of experiments with a high throughput platform, so you can perform several experiments at once, and you're trying to make measurements that quantify the quality of the experiment, and you're trying to optimize the experiments by obtaining larger values of your measured quantity. And so what PDT does is actually tell you what experiments to perform. You perform those experiments, and then you upload the experimental results into PDT, and PDT works in the cloud to build a model of your experimental response surface and do many virtual experiments, and then predict what the next generation of experiments you should do in order to improve your results. To create a new experimental campaign, you press this New Session button, and this will create another button down here at the bottom, and this button will have a name, and you can enter a short description. And when we push this Create Session button, we create a new session for a new experimental campaign. We're informed that a new session has been started. We begin that new session by going to the Experiments tab here. And on this page, we have a little diagram down in the lower left corner that describes where we are in the use of PDT. The first thing we do is to actually define the experiment. And these are defining the experiment for the entire campaign. There are two different types of experiments we can perform: factorial and mixture experiments. This tour will only explore factorial experiments, and for factorial experiments, we presume that your experimental implementation can take you to all possible experiments in the experimental space. Mixture experiments, on the other hand, are relevant when you have a constraint, like, for example, in the total number of drops that your robot will put in a well. But we're going to do factorial experiments in this tour, and the experimental space is essentially defined by this table. In the table, we have names of experimental parameters. Here, there's only two experimental parameters listed, and for each experimental parameter, we have some number of values that parameter can take. For parameter 1, we only have 2 values, and for parameter 2, we have 4 possible values. To specify an experiment in this experimental space, we must specify one value for each of the parameters, like parameter 1 is equal to 1 and parameter 2 is equal to 2 would specify an experiment. If we want to add parameters, we can do so by editing this table by creating new rows in the table. If we want to add new possible values, we can add columns. On the other hand, we can also paste into this table directly from a file where we might have an experimental space definition stored. I happen to have over on the side here a file, an Excel file that has an experimental space definition. And what I'm going to do is I'm going to drag out the cells that define the space, copy them from the Excel file, and then come over to the table and paste them in. So you can see this experimental definition has 7 different parameters with these names, and each of the parameters has some range of values. After you've defined the space with your experimental parameters and the ranges of values that they can use, you can specify 2 additional parameters to determine the experimental campaign. One is the population size, which is the number of independent experiments that you will have in a generation. And the second number is the number of replicates that you will have of each experiment. Usually replicates are used to reduce noise. So once you've defined the experimental space and these generation parameters, we can click the button to save the experimental space definition. We now arrive at the initialize phase of the PDT process, and in this view we can upload any initial experiments which we may have performed either from calibration runs or previous explorations. I happen to have a few initial experiments just for demonstration purposes, and I'm going to sweep out these initial experiments, copy them, and from my Excel spreadsheet, and then I'm going to come over here and paste them into the table. Notice that each experiment here is a row, and each column is one of the parameters. The column names are the parameter names, and the response is the experimental response that was measured for that experiment. After I have finished entering all my initial experiments, I can save these results and ask PDT to design my first generation. This may take some time if the experimental space is complex. This one is relatively simple, and so PDT finishes its job relatively quickly. Down here in this table, we see that PDT has proposed a set of experiments. How many experiments? It's proposed 90, consisting of 30 independent experiments with 2 replicates each. And so the first thing you may want to do is to download this experimental design so that you can take it to your lab and perform the experiments. You may want to leave this view of PDT and come back once you've finished the experiments. You can do that by logging out or by killing this window. And then when you've finished the experiments, you can log back in. And you see here is the experimental campaign that we were working on. And we press this button, and we should come back to our restarted session. And when we go to the Experiments tab here, we should find exactly the same table of the experiments in generation 1 that we left. Now, however, we have the responses. I happen to have some experimental responses here. And once again, we can simply copy them from a file and paste them in. And once we've pasted them in, we can save these results to design the next generation, generation 2. Generation 2 is now designed, and PDT is now waiting for these generation 2 experiments to be done and the responses to be uploaded. Continue this process for many generations, and I will now enter generation 2 experiments and a few more generations in sped up time here. And finally, we finished 8 generations of experiments. And now I think we can proceed to illustrate a couple of other features. One is this data tab, where we can see historically synopsis of all of the experiments that we've been doing. We start with the experimental space definition itself, and this may be downloaded for your records if you like. And here we have available all the data from all the previous generations, and we can choose a generation, and that data will appear, including both the experiments and the responses. And these tables may also be downloaded for your records. On this tab we have analytics, which gives a variety of elementary analytics displaying what happened in this experimental campaign to date. The first analytic graph is a bar plot, time series bar plot, where we simply graph the responses generation by generation. This was our first generation, second, third, fourth, fifth. If PDT is doing its job, you should see the average response go from low values to higher and higher values. And we've chosen experimental responses to illustrate this as a successful campaign. You should not expect the results to increase in value monotonically. For example, in this generation, we see that the best experimental result was here, and in the following generation, it was actually lower. This is because of stochastic sampling and because the model is never perfect. And so it can make mistakes when it's trying to predict the good experiments. There's a variety of other analytics here. Rather than show them all to you, I will point out that the explanations can be found here in the PDT's analytics documentation. Note that these analytics are produced in PDF format, and you may download these PDF files to your computer using your browser's PDF interface. For this browser, this is the download button.
This concludes our tour. I hope you've enjoyed it, and I hope that we will see you back at protolife.com to enter your own experimental data and achieve even better results than we've seen in this little demonstration.